Good morning to all. Now I am going to explain the reaction mechanism. So here, first order reaction is even reaction, even elimination reaction. Evidences. So evidences for the even elimination reaction. So generally, even elimination reaction, evidences is that the reaction proceeds through the first order kinetics. Because in the even elimination reaction, the rate of reaction mainly depending on the substrate molecule concentration only, but not depending on the attacking agent. So in the even elimination reaction, the attacking agent is the base. So the mainly which involvement in the only even elimination reaction, the rate is mainly depending on the concentration of substrate molecule and independent of the concentration of the base. So here mainly in the even elimination reaction, the solvent effect, the rate of reaction. So no solvent effect on the rate of reaction. So solvent is not influence the rate of the reaction in the even elimination reaction. This can be proved by adding the conjugate base of the solvent. This can be proved by the adding conjugate base of the solvent to the reaction mixture. So it is found that the rate of the reaction does not change. So first one, evidence is first time. So the reaction mainly, reaction is even elimination reaction proceeding through proceeding through first order kinetics. First order first order kinetics. That means that is rate is depends on depends on concentration of reactant species. Reactant species and independent of concentration of base. Independent of concentration of base. So with respect to the in this even elimination reaction, with respect of the S substrate molecule, the rate is a 1, and with respect of the base, the rate is a 0. So the overall rate is mainly depending on the S substrate concentration only. Next one, here another evidence is a solvent effect. So solvent effect. So in even elimination, there is a no solvent effect. There is no solvent effect. So second is what is the no solvent effect on order. So yes, solvent effect, no solvent effect on order of the reaction. Order of the reaction. Order of the reaction. So rate with respect to rate is equal to some concentration of the solvent power 0. So therefore order is equal to how much with respect to solvent is a 0 order. So therefore the rate of reaction not depends on the solvent. So this is the one of the evidence. Next one, when the reaction is performed on two molecules, they are differ only living groups. If the reaction is carried out, if the reaction is carried out, or if the reaction is performed on two molecules, they differ in the only living groups. The rate should be different since they depends on the living ability. They depends on living ability of the molecule. For example, we are taking the different molecule. Yes. So here tertiary butyl bromide and tertiary butyl chloride. So these two are the two molecules, tertiary butyl bromide and tertiary butyl chloride. Two molecules is there. So these two are the taking in the reaction result and add the solvent and add the base to the reaction mixture. To the reaction mixture. So in this case, this molecules rate is will be different. So since here the leaving groups are the different. One is a Br, another one Cl. So this is mainly your rate is different because depending on the yes ionizing ability of the molecule, which is a more ionizing. Yes, the Cl is a more ionizing compared to Br. So therefore the rate is different. Yes, and in the also in this here first step is a rate determining step in the even elimination reaction. Second step is a yes what happened not rate depending step rate determining step. First step is a slow step because it undergoes self dissociation of the substrate molecule before attacking at the base. So this step is a self-dissociation from the one of the living group from the substrate molecule is a difficulty. So that's why the reaction rate is slow. Once here Cl minus lost, then generation of the which is the carbocation intermediate is generated in the even elimination reaction. The carbocation intermediate further here in the presence of base, so base is taking here carbocation adjacent to carbon having proton is taking. Then it is a formation of the pi bond formation. This step is a fast step. So in the second step is a fast step is a slow step. So second step, solvent effect and temperature are the same for the both the molecules. Solvent effect and temperature are the same on the second step. So here second step is there. Therefore, this indicates that the nature of living group does not affect the second step. Nature of the living group only affect the first step, but not affect the second step. Okay. Second step rate is not affected by the solvent or temperature. So this is another one evidence for the even elimination reaction. So even elimination reaction. So therefore here what is there? Third factor is a living group. So here Br is a one living group. Here Cl is a one living group. The living groups is mainly is affects the step one rate, but not the here fast or slow. That is only affect the first step, but not affect the second step. Next to fourth factor, fourth evidence is the S solvent temperature, solvent comma temperature no effect, not affect the second step. So second step, these two are the similar. These are the evidences for the even elimination reactions. Even elimination reaction. Take a screenshot. So next one, evidences for the E2 elimination reaction. So E2 elimination reaction evidences, E2 elimination reactions evidences. So E2 this here E2 elimination displays second order kinetics. E2 elimination reactions displays second order kinetics. When beta hydrogen with respect to the living group, when beta hydrogen is replaced by deuterium, therefore kinetic isotopic effect is observed. Yes, in the E2 elimination reaction, with respect to the living group, the beta hydrogen is replaced by the deuterium. The kinetic isotopic effect is observed. Kinetic isotopic effect is observed. This indicates that the removal of beta hydrogen from this from beta hydrogen atom takes place is in the rate determining step. So, and E2 elimination reactions is a stereo-specific reaction. So, this mainly here E2 elimination reaction achieved by the here or happened by the two ways. One is the anti-elimination, another one is a syn elimination. Good morning, Sinu. Good morning to all. So evidences for the E2 elimination reaction. First point, it is a displace or it is proceeding second order kinetics. So first one, evidence is a it proceeds through second order kinetics. Second order kinetics. Second order kinetics means rate is depends on concentration of the substrate molecule, concentration of the substrate molecule, and concentration of the attacking agent. Attacking agent. So attacking agent is which is there used as a base. So these two species is involves in the rate determining step. These two species involves in the rate determining step. So that's why the rate is mainly depending on the species which are involved in the rate determining steps. Those and power. So here how many species? Here one, their power is one. Here this species is a power is one. Some of the powers are the reacting species in the rate determining step. In the rate determining step, here involvement the species is a mainly two. Here one is a substrate molecule or reacting molecule. Another one is a attacking agent, that is a base. Base is taking the proton from this one. So this step is a slow step and rate determining step. In this step, the rate is mainly depending on the concentration of the substrate molecule as well as the concentration of the base. So therefore, the order of the reaction is equal to sum of the powers of the reacting species in the rate determining step. So in the rate determining step, here species involvement is one is a substrate molecule, another one is a base. Therefore, order is equal to how much? Here 1 plus 1, 2. So order is equal to 2. Order of reaction 1 plus 1, here 2. So this is which is there second order kinetics and bimolecular reaction. Bimolecular reaction. Bimolecular reaction means in the rate determining step, here environment species how many? Two species. One is a substrate molecule, another one is a attacking agent base molecule. And one more important factor for the impacted evidence is that here with respect to the living group, beta hydrogen is replaced by the deuterium, the kinetic isotopic effect is observed. So another evidence is that when beta hydrogen is replaced by deuterium, beta hydrogen is replaced by deuterium, then kinetic isotopic effect is observed. Anti-isotopic effect is observed. So this kinetic isotopic effect is not observed in the case of the even elimination reaction, but the kinetic isotopic effect is observed in the E2 elimination reaction. So in this case, what happened here? Here, for example, this is a H, here living group is there. So this is the with respect to living group attached carbon alpha and then additional carbon beta. Beta carbon are the hydrogen. So this hydrogen is replaced by the deuterium. So this hydrogen is replaced by the deuterium. H can be replaced by the deuterium. So the rate also changes. The rate of the elimination also changes. So with respect to hydrogen is replaced by the deuterium. So this is which is there beta position. Beta position deuterium is there. Rate also changes. So once the ratio this rate is mainly kh by kd. That's what happened. Here this is 3 to 8. 8 times changes. 3 to 8 times changes. So this kinetic isotopic effect is observed in the case of the in the case of the E2 elimination reactions. And one more point, the kinetic isotopic effect is not observed in the case of the E1 elimination reaction. E1 elimination reaction not observe the kinetic isotopic effect. So therefore, here KDH by KD, nothing but the rate of the this step compared to this one, nothing but the here what happened elimination compared here elimination, the rate is what happened changes variation. So this indicates that the removal of beta hydrogen atom takes place in the RDS step, rate determining step. And E2 mechanism is a mainly stereospecific reaction. Or stereospecific means reactant stereochemistry is retained in the product. So that is a stereospecific. Okay. Next, one more point is the evidence is the E2 eliminations. E2 elimination. E2 elimination reactions are stereospecific. 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 So stereospecific means a reactant stereochemistry is retained in the product. That is a stereospecific. So please take a screenshot. Okay, next one, the E2 elimination reaction proceeding into two ways, or it can be happens in two ways. One is a anti-elimination, another one is a syn elimination. Anti-elimination means the leaving groups are the one to another diagonal angle separation is 180 degrees. Syn elimination means the leaving groups, the dihedral angle separation is 0 degrees. So E2 elimination, this can be happen in two ways. Two ways. So one is a yes anti-eliminations, and another one is a syn eliminations. Syn eliminations. Anti-eliminations and syn eliminations. So this can be happens in the two ways. One is an anti-elimination, another one is a syn elimination. So here, first one anti-elimination. So in anti-elimination, yes, in this elimination, two eliminated groups oriented in trans manner. Two eliminated groups oriented in the trans manner or anti-manner. So in these eliminations, first of all, we are taking the molecule in the form of the Sahar's projection. In this, which type of Sahar's projection? Anti-trans Sahar's projection or staggered Sahar's projection. So Sahar's projection, how to representation, madams? So first of all, taking the one y type. So another one taking the one y type, and in between the connected by the diagonal line. So here what is there? Y type, one of the carbon, Y type. It means here to here how much angle separation? 120 degrees. Here to here how much angle separation? 120 degrees. Here to here how much angle separation? 180 degrees. So the total how much is there? 360 degrees. So here also same. But here, this is a take and keep about this one. What happened? One to another is a matching. And means one is exactly yes above the other one. So this is called as a eclipse. Eclipse. Okay. So here eclipse how to see here. For example, so this is a x is there, x. Here y is there, y. Here z is the z. So observer is seen this way or in this direction. So this is a nearer to observer. This is called as a front carbon. Front carbon. So this carbon is away from to the observer. So this is called as a back carbon. Back carbon. Generally denoted as a BC, back carbon. A front carbon means FC. So what happened? This observer seeing this direction, look in this direction. The x is this x is exactly backside of this x, and the y is exactly backside of this y, and z is exactly backside of this one. Means these two are separation angle. These two separation angle that can be denoted by phi. This angle is called as a dihedral angle. Phi is called how much? This is called as a dihedral angle. Dihedral angle. So here dihedral angle, how much is there? This is the 0 degrees. For example, you take the y like this y is exactly backside of this one. Means your angle's direct angle separation 0 degrees. This is also exactly backside of this one. Dihedral angle is a 0. Therefore, this is called as a dihedral angle is equal to 0. Therefore, what happened? This conformation is called as a Sohers eclipsed conformation. Eclipsed conformation. Sohers eclipsed conformation. So but if you take the elimination reactions, here elimination reaction, mainly two type of eliminations. One is a syn elimination. Syn elimination mainly the leading groups here angle separation how much is requirement? 0 degrees requirement. So but here another conformation is there, another conformation. So that is a which is there here main requirement which is there here this are 180 degrees angle rotation. So this is the angle. So rotation. Which carbon? This one are your choice, this one are your choice. Because your rotation is possible, CC bond is there. CC single bond, CC rotations are possible. Now I am do this one, yes, which is there, back carbon to the 180 degrees in which direction? Clockwise direction. Which carbon? BC, back carbon. This symbol is indicated the rotation symbol. This is a direction, either clockwise or anti-clockwise. That is your choice. Which carbon? Either front carbon, back carbon. That is your choice. So now I am doing the CC rotation by the back carbon. How much angle? 180 degrees. Once 180 degrees rotation. So therefore, what happened? This carbon is no changes. Only the back carbon is changes. Why? So this is the only changes. This one. So what happened? The x is going to here to exactly here, and the y is going to the exactly here. Y. Next, this z is going to here. Okay. So the resulting is this is a diagonal line. Here first front carbon is no changes the direction. So this is the Z group. Yes, here Y group, here X group. Okay, here back carbon is a gets exchanged completely. Yes. So what happened? So this Y is goes to here. Yes, X is goes to here. Next to Z is goes to here. So therefore what happened? These two are so Z and Z. So X and X, Y and Y. The any you take the any similar kind of the groups is there in this molecule. The angle separation that is a dihedral angle separation. How much is there? 180 degrees. Not a bond angle. It is a dihedral angle. So bond angle means so those bonds are connected to a single point. In between these angles called as a bond angle. Bond angle can be denoted by theta. But these two are the groups are not present on the same carbon. They are present in the different carbon. Therefore, the angle separation is called as a dihedral angle. Dihedral angle. So here dihedral angle, if you choosing the two Z groups, Z here, Z here. Your angle separation is how much is there? 180 degrees. Which angle? Diagonal angle is a 180 degrees. Therefore, this conformation is called as a Sauer's anti-conformation. Anti-conformation. Sauer's anti-conformation or staggered conformation. Staggered conformation. Anti-staggered conformation. So the living groups, for example, we are choosing the living groups. The Z groups is the living groups. Yes. So for example, we are assuming the Z as a living groups. The living groups angle separation, which angle? Dihedral angle separation. How much angle? 180 degrees. Therefore, this is called as a, so the groups is a, in the presence of attacking agent. Attacking agent is nothing but the one of the taking B. B nothing but the base in the elimination reaction. The B is attacking to this Z, one of the Z. The bond is what happened, the bonding reference is shifting and the bonding reference is removal. So what happened? So attacking agent and the bond is a bond electron donating to this one and last, and this is taken by the bond electron, then formation of the double bond. So in this case, what happened? Here formation, this is the called as a here anti-elimination. So in this anti-elimination, we get the transition state is obtained. Transition state nothing but the bond breaking and bond making takes place simultaneously. Here Z group. So remaining X, here Y, here. Next one here X group, here Y. And here bond formation is takes place here in between the here. So here which is there? Here base. So this is called as which is there transition state. This transition state, which type of transition state? The living groups is an anti-separation. Therefore, this is called as a anti-periplanar transition state. So your formation of the transition state is a anti-periplanar transition state. So this anti-periplanar transition state, this is can be denoted by the APPEST, anti-periplanar transition state, and it leads to the elimination of the two Z groups and a formation of the which compound is formation? Trans compound is formation. So here Y, X, here X, Y. The same kind of groups at the double bond is opposite side, and the same groups are the opposite side. Therefore, which is formation? Trans formation. And this is formation of the major product because at the transition state, the same living groups, here there is a no repulsions is there because they are separation by the high angle separation, high dihedral angle separation. There is a no steric repulsion between the living groups. Therefore, it is a fast reaction. But it is approaching base is a, this step is a slow step. So slow step is how many species involvement? Two species involvement. One is a base and another one is a reactant. Therefore, the molecularity is the bimolecularity. In rate determining step, here the involvement species is 2. Therefore, it is a bimolecular reaction. And this bimolecular reaction, here what happened? Here bond breaking, bond making takes place in the simultaneously. This bond is a making and these two bonds is breaking in the presence of the external species, that is a base. So therefore, here formation of the transition state, which type of transition state? Periplanar transition state. Which type of periplanar? Anti-periplanar transition state. So the living groups is anti to each other. So then it leads to the formation of the trans product is a major. Please take a screenshot. So here simply taking as an anti-elimination and cis-elimination. So this is the in the Savar's form. Here this is the so this is the x. These two are the which is the anti-manner. Therefore this is a here we are adding to base. So then the bonding electron shifting and this is lost. This is called as a anti-periplanar transition state. It forms a anti-periplanar transition state. Next one, the because the dihedral angle between the selected living groups is how much is there? 180 degrees. So therefore, here and another one is a same periplanar transition shape. The living groups angle separation is the same. How much? X two groups is there. Living groups here angle separation that is 0 degrees. So y is equal to 0 degrees. So which is there? This is sin conformation or sin conformation. Nothing but eclipse conformation. In this eclipse conformation, your formation of the same periplanar transition state. So whenever we are adding to the base, so base is the bonding electron shifting and this can be eliminated. So here what happened in between the living groups, steric strain is observed. Steric strain. So steric strain is present. So here no steric strain. Steric strain. And here also here same groups is same here same side and angle separation 0. So here which is there eclipsed strain is present. Eclipsed strain. So here no eclipsed strain. No eclipsed strain. So this conformation is called as a staggered conformation. Staggered conformation. So this conformation is called as a eclipsed conformation. Eclipsed conformation. So how to say eclipsed conformation? In the conformation, Savar's conformation, the same groups angle separation, that is a dihedral angle separation, 0 degrees. Therefore, it is an eclipsed conformation. Here, same groups dihedral angle separation, 180 degrees. It is a staggered conformation. So in this case, here see here what happened. Living groups is a angle separation 180 degrees. Therefore, it is a anti-conformation or staggered conformation. Here eliminations is a fast because no steel crowding is there. Whenever in the case of the sin or say here sin complex, here sin elimination, the living groups angle separation that is a dihedral angle separation 0 degrees and 0 degrees. Therefore, a steric crowding or steric repulsion is arises between the living groups. So steric strain is present. Therefore, the eliminations are slow and formation of the minor product. And this is called as an eclipse conformation. Whenever the selected groups angle separation is 0 degrees, the conformation is called Sahar's eclipse conformation. Whenever the selected groups and diagonal angle separation is 180 degrees, therefore the conformation is called as a Sahar's anti-conformation. So Sahar's anti-conformation proceeding through anti-periplanar transition state, whereas the eclipse conformation, your eliminations proceeding through sin periplanar transition state. Sin periplanar transition state, the rate is very slow compared to anti-periplanar transition state. That's why most of the cases anti-periplanar transition state and anti-eliminations are preferred compared to sin eliminations. Thank you to all.